The purpose of the demo is to show how we can build a forecasting model that can accurately predict bandwidth requirements for a particular telecom company based on the customer demands. So for this analysis, I'm making use of a technique called as time series modeling, which essentially helps us in forecasting a data, specifically time series data. Time series data is obtained by making observations at a regular interval on a particular parameter. So here I'm making use of two types of time series data. One is the monthly user subscription data for the last 5 years. So when I say it's time series data, what essentially I have is what was the subscriber base at the beginning of the month for every month for the last 5 years. So 1st of Jan, 1st of Feb, 1st of March, say from 2010 to 2014, for those 5 years, what was the subscriber base for each of those months at the beginning of the month. And I also have the second data, which talks about the average bandwidth utilization for the same geography for the same time interval. So for the 1st of Jan, 1st of Feb, 1st of March, for each of those years, for all 12 months, what was the average bandwidth utilization? So based on these two data sources, I'm going to accurately predict what would be the subscriber base, say from 12 months from now or 2 years from now, and what would be the corresponding bandwidth requirements for supporting that subscriber base based on the historical data and the current data that we have. In terms of business values delivered to the CSPs, primarily I could list down three of them. First and foremost is an enhanced capacity planning for all the future needs. So based on this analysis, you would be able to identify what is your bandwidth requirement, say 12 months from now or say 2 years from now, so that you can plan your resources accordingly to ensure that level of bandwidth is available for your customer base. You can also optimize the management cost for your bandwidth. So if you know that a particular bandwidth is going to be not required and you can reduce it to support your current subscriber base, you will be able to redirect that cost into another area where there might be a requirement. So you can optimize the cost based on the results coming out of this analysis. The third business value that can be delivered is the improved user experience. So when you know that a particular subscriber base is going to require this level of bandwidth, you can proactively plan to ensure that level of bandwidth is there so that you can support the subscriber base and they would not face any network related issues when they're using the products or services provided by the telecom company. So for this purpose, I am actually making use of IBM SPSS Modeler as the tool for all the data mining purposes, and the results can be projected using the output mod nodes that are available in the tool itself. Yeah, as you can see, this is the prediction model that we have built, making use of the customer data that we have, the subscriber base and the bandwidth utilized for the last 5 years. And this is the prediction graph. So the area that you see after the dots are getting over is the predicted one, the forecasted values. So that sort of tells you what would be the future subscriber base and the future bandwidth requirements based on the historic data. This is the IBM SPSS canvas in which I've already developed the model. Let's go into the demo straight away. So first you have the monthly subscription data and the monthly average bandwidth utilization. I'm merging this two based on the date field. So the common field between these two data sources is going to be the date. So what was the subscriber base on 1st of Jan and what was the corresponding average bandwidth utilization? So this is the table node which I have added. If you want to take a sneak peek at the combined data, this is how it's going to look like. So you have the date field that is common between two data sources, and you have the 5 different states, and what is the corresponding subscriber base at each of those states on these particular states. And you also have the average bandwidth utilization on those states on those particular dates for all the 5 states. And you also have the total subscriber base. If I move this a little bit, yeah, so you have the total subscriber base, and you also have the average for all the states put together in terms of bandwidth utilization. The next step is to understand the data a little bit more so that you can decide the future course of your analysis. I'm interested in a couple of particular things here. The first one, can I eliminate any of the input data that is not going to be required for the analysis? So when you analyze the information, you see that there's a date field which also carries a year and month, and you also have a year field and a month field, which is pretty much redundant. So I am removing that as the first step. Second, I would like to see if there are any seasonal parameters, patterns available in the particular data. Say, when I say seasonal, every year in a particular period, say in the months of summer or months of winter, is the subscriber base going up or utilization going down, something like that, so that there is a particular pattern that can be observed seasonally across all 5 years. So this is going to determine the course of my analysis. So there are a few nodes that I've added here. So this one basically takes the subscriber base for all the states, so states, all 5 states that we have used, and if you run this, it will generate a graph that looks pretty gradual and smooth across all the 5 years. So I do not see any seasonal trends in this particular data set that I have. The next one is the total subscriber base across all 5 states. Again, as you can see, there's no sudden increase or decrease or periodical increase or decrease with respect to the data. So it looks like a gradual increase across all the years. So there, I don't see any seasonal data in this data set. The next is to check whether there is any change in utilization seasonally. So we saw that there was no change in terms of subscriber base. Is there any change with respect to the utilization of the services? That is also something which we have to see. So I'm generating a graph that shows the average business, utilization or bandwidth utilization across all the states for 5 years. So as you can see, there is no sudden increase or decrease on a periodical manner here. So which means that there is no seasonal data available here. If there were, if we had seasonal data in the data set that we have, so in that case, what we need to do is make sure that we analyze the data differently. So the seasonal data needs to be analyzed separately, and the normal data needs to be analyzed separately to identify the patterns, because putting them together, seasonal data would come out as outliers, and the model that we are going to generate may not be able to accurately predict the ups and downs of your data. Okay, so the next part is it's a very important part here. Since we are going to use time series analysis, the input to that particular node needs to be a particular interval. So in this particular tool, IBM SPSS modeler, when you give date field from any input data source, it's read as a string, but we need to make sure that the date field is read as date, so that we can actually calculate the intervals, say yearly or monthly or quarterly, and your model will be able to understand what is that input value that's coming in. So this is a particular filler field which I've added, which converts the date field into the format that is required. So this converts a string into a proper date field. So this is pretty important. And you also have to ensure that the tool reads the date in a proper manner. So the format of date used here, let's take a look at it. It's in MMDD YYYY format. So you need to ensure that the tool is also set to read date in that particular manner, so that your fields can be read as it is without any errors and so on. So this field, this particular node that we have added, is very important in this analysis. So how do we ensure that's the case? So you go to tools, you go to stream properties, you go to options, you see the date and time field here, and you have to change the date format to MMDD YYYY from whatever it is set as default. So this is an important step, and this needs to be done based on what is the input field that's coming in. So if your date field is coming as MON space YY format, then that needs to be the input value given in this particular tool. So take care of this before proceeding with the analysis. The next step is I've added a type node here to basically indicate what are the target fields and what is the input field here. So since we are going to do time series analysis, all the fields that we have given from the data source is going to be a target field, because for each of these fields we will have a forecasted value coming out. So as you can see, everything is target, and except for the date field that needs to be set as none, everything is set as target here. And once that is done, I have added a couple of time interval fields here, so I will get to that later. First, I'll go into this. This is one of the time interval nodes that I've added. So I indicate that the time interval is going to be months, and it needs to be built from the data. So this is the date field that it can use to determine what is the interval. So this is why we have changed the field to date in the previous step. Another important aspect is go to the forecast tab, and you can extend the records into how much ever intervals you want. So we have taken months here. So when I put 12, the model that is going to be generated is going to forecast subscriber base as well as bandwidth utilization for the next 12 months. And that will be indicated by this particular field that will get added to the current data set that we have. Once that is done, I'm adding a time series node here, and there are multiple options, models that are available to build a time series model here. So one of the algorithms is the expert modeler option, which will in turn make use of multiple algorithms as it deems fit. So we don't have to worry about which algorithm is going to predict an accurate forecast model when we are using expert modeler. So that's a built-in intelligence that comes with this tool that can pick and choose the right model to go ahead with the analysis. And there are other options over here. As you can see, there's exponential smoothing and ARIMA options which we can use, but that's for an advanced level of analysis. So once we choose expert modeler, we are going to run this particular model, and if this box is checked, you need to uncheck it because we don't have any existing model, so it needs to build the model on its own. So when you run it, this is the model that gets generated. So the next step for us is to go and take a look at the model that is generated. As you can see, these are the target variables, and since we have used expert modeler, it has used different kinds of algorithms to predict those particular models. And these are the important fields from a statistics point of view. This is the degree of freedom, and this is the significance value. To predict whether to establish whether the model that we have generated is a good model for our purposes, the significance value has to be greater than 0.05. So if you get a value which is less than 0.05, then essentially that model is not accurate. This translates into a typical problem which says there were underlying trends and patterns in the data that was not effectively captured by the model that was developed. So we need to go back and do an experimental analysis on the data which has developed a insignificant model as an output for our case. But a quick look at it, everything is greater than 0.05. So this is 0.4, 0.4, 0.9, and so on. So everything is greater than 0.05. So we are good with this model. Another thing which we can do is go to the advanced part here and check for the R square value. So this should be as close as possible to 1. So we have 0.999 to 1, 0.997. So our model, I mean, whatever this is reflecting, it means that the models that we have generated are good enough for our analysis. So we'll take a look at the output table that gets generated as a result of this particular model. So you have the original data that's coming in, and you have 12 new rows that gets added as a result of this analysis. So each row corresponds to a particular month that was forecast into the future, and all these values are null because we don't have the original data, so it gets populated with null. but when you scroll towards this side, this is the column that indicates whether this is future data or the current data. So zeros indicate that this is current data, and ones indicate that this is the future data. So you have 12 rows of 1, which indicates that we have created a forecast for 12 months in future. So as you can see, the original data had values till December 2014, and the predicted data has values till December 2015. So we have predicted how the trends are going to be in terms of user base and utilization of bandwidth for the next 12 months. These are the values. So this is for the state of IL, which has these values. So the last observed subscriber base was 11,721. So it keeps going up and down. So based on that, what we have seen is 11,713 is going to be the new subscriber base at the end of the year based on the historic data that we have. Similarly, this is the lower confidence level and the upper confidence level. So this could be the range in which this is the lower range and this is the higher range between which the predicted value is going to be. So that's what this table means. Similarly, we have for all the states, and we also have for the total subscriber base here. So this is the time series for total, and this is going to be the total subscriber base at the end of December 2015, or at the beginning of December 2015, because 1st of December is when we are making the observations. Similarly, you have data for the average bandwidth utilization for each of those states. This is the time series model. This is the lower confidence level and the upper confidence level. So we are predicting or forecasting that the bandwidth utilization in the state of IL is going to be around 62.5 at the end of 2015. So similarly, you have the bandwidth utilization data for all the states into the future, and we also have the average bandwidth utilization data for all the markets put together. This is somewhere close to 68%. So now we have to ensure that the model that we have generated, the values that are getting generated into the future, are actually a true reflection of the historic data. So one way of doing that is creating these time plots here. So I am using a time series model plot over here. So I'm going to plot the time series data for the state of IL as well as the average bandwidth utilization for the same state. It will indicate whether the model is accurate or not. So as you can see, the dots indicate that this is the the actual value, and the line indicates the predicted value. So as you can see, the dots and lines are pretty much on the same spot here. So this is the historical data, and the model was able to learn from the patterns and predict the line. So our model is pretty accurate. That's what this means. So as we can see, after the dots are over, this is the December 2014, and the models and the value over here is going to be the future value until end of December 2015. And this is the upper confidence level and the lower confidence level value here. As you can see, once we go into the future area, the upper confidence and lower confidence starts to broaden. So in an ideal telco setup, what we would do is we would do this as a one-time analysis to see, okay, what is it going to be a year from now or 2 years from now. But the range, as you can see, as we go further away, it's going to keep broadening. So the level of accuracy may or may not be right, because the subscriber base and the utilization might change over a period of time. So it is always advisable to go for shorter durations, say 3 months or 4 months, and make use of the data that could be the actual data in the next 2-3 months, and see if our model is still relevant, and keep going on an incremental basis for every 3 months or 4 months. So that's like a typical best practice that we follow in telco setups. Similarly, I have generated graphs for all these fields, and see, as an output to somebody who's going to be interested in understanding bandwidth utilization based on customer demands. Say we can add a select node here and say he or she wants to see a set of records or states or subscribers uh, where the utilization is going to be above 60%. So we can add that. This is the time series average, so this is the predicted value for which is greater than 60. And when we connect that to a table, it extracts data with the average average bandwidth utilization, which is going to be greater than 60. And as you can see, that's what the case is here. This right away gives a valuable input saying, okay, if 60 is going to be the threshold, then you know that these areas are going to be in critical state sometime in the near future, and appropriate actions can be taken by the person who's responsible for ensuring capacity is maintained and so on. And as I mentioned previously, predicting something for 12 months is something which you can do as a one-time activity to see if there's any risk involved in terms of the current bandwidth and the utilization. In a typical telco setup, what we would do is predict it for every 3 months. So this is the other time interval, and the forecast is for the next 3 months. And I'm going to generate a model using expert modeler, similar to the one which we did previously. And this is the model that gets generated as a result of it. So let me generate it. So the next step for us is to ensure that this particular model is being implemented in the new fresh data set. So what we have done is we are making use of two new updated data sets, which has data coming from the next 3 months. So you have 2015 data for Jan, Feb, and March, and we have forecasted the same data for Jan, Feb, and March using this particular time series model, and we are implementing that similar fashion to the previous analysis to see if the data is generated appropriately. So these are the new models that get generated. Similar for the state of IL. This is the predicted model, and this is the actual what has happened. So you can see the data is pretty much equal. So our analysis is good, our data model is good. The model that was developed has actually predicted, and the actual data is pretty much in sync with what we have predicted. So this is the data for the next 3 months. So this keeps happening, and if we see there is a reason for us to do remodeling of this data, if the forecast data and the actual data is not in sync, then we would go for a remodeling and a new fresh data analysis. Otherwise, we can keep reapplying this data as and when new data gets applied to your data sources to see if the model is still relevant and whether it can still predict how the capacity is going to be and how the subscriber base is going to be for the next 3 months or 6 months. So that's about this demo. Thank you.